equilibrium. When we say the body is in equilibrium, that means the summation of all forces equal to 0, and the summation of all moments equal to 0 as well. The most important step in solution of problems is the free body diagram. To draw the free body diagram, actually we have some cases that we have to take it into consideration. The first one, if I have a flexible belt, cable, rope, I need to put in a state of this rope attention, and the body into consideration must be the body under study. Second case, if I have smooth surfaces, I will put a contact force and the action of the body to be oscillated, and this force must be perpendicular to the surface under study. If I have rough surfaces, I need to put two forces, one tangent to the wall, and the second one is perpendicular to the surface. One tangent to the surface, and the second one perpendicular to the surface. The fourth one, if I have ruler support like that, I will put a normal force perpendicular to the surface. Here, for example, if I have ruler, rocker or ball supports, so I need to put compressive force normal to the supporting surface. If I have freely sliding guide like that, I need to put a normal force to the guide. The guide, I put normal force, just one force. If I have pin connection, actually we have two types of pin connection. One is free to turn or free to rotate, so I need to put two components, one let's say in the direction of X, and the second one in the direction of Y. If the pin connection is not free to turn or not free to rotate, I need to put two components or forces and one moment or couple. Seventh case, if I have built or fixed supports like that, I need to put two forces and one couple. If I have gravity, let's say gravitational attraction, okay, I will put in state of mass, put a weight, a force, always downward, okay, or let's say toward the center of the earth. The last one is spring action. If I have a spring here, so I need to put just one force, and this force is equal to K multiplied by X. K is the spring stiffness or spring property, and X is the deformation of the X. Now, how can I draw the free body diagram? First of all, I need to decide which system to oscillate, which is the body should be under study. This is the first step. The second step, next oscillate the chosen system by drawing a diagram which represents its complete external boundary. The second step, I need to oscillate the chosen body, okay, and drawing the diagram that represent complete external boundaries. That means I will have the external boundary only, regardless what I have inside this system or the body. Step 3, identify all forces which act on the oscillated system. So I need to specify all the forces that acting on the oscillated system or oscillated body as applied by removed contacting and attracting bodies. We put all the actions that we have talked about here in the 9 cases. The last step, or the fourth step, show the choice of coordinate axis directly on the diagram. I need to draw appropriate the coordinate system. Actually, we have here some examples of free body diagram. This is the example number 1. You can see I have a thrust, there is a force, pin connection, ruler. Okay, now you can see in the free body diagram I have an external boundary only, and there is the force, it's the external force, pin connection, two forces, one in the x-axis, one in the y-axis, and this is in the direction of y. Now you can see I put, or I need to identify the the reference axis, or let's say the coordinates. Now you can see this ax, that's mean this is the force or the reaction in the x-axis, and this one in the direction of y. And the ruler, as we know, we have just one force, and this one force is perpendicular to the to the surface or towards the y direction. Now it is not important which direction I put. For example, ax in this direction, to the left or to the right. It is not important. Why? Because if I put ax in this direction to the left, and the result is in minus, that means I need to opposite, or to change the direction of the ax. If I have cantilever beam and there is a mass, the weight, the first important, the weight should be in the middle of the body. The weight must be in the middle of the body, and this is the x and y. Now you can see I have all the external forces besides the fixed or built-in beam. So I need to put two forces, one in the direction of x, one in the direction of y, and moment or couple. Beam with a smooth surface, contact at a smooth surface, and there is a mass. Again, do not forget, due to I have a mass, I need to put the weight downward, vertically downward, always towards the center of the earth. And this weight always, this is very important note, must be in the center of the body. Now you can see I have the couple here and the external force. Now what about connection beam? In the connection pin, I have two forces, one in the x-axis, one in the y-axis. Due to I have smooth surface, I need to put just this reaction, just this force, and this force should be perpendicular to the line, perpendicular to the surface, must be perpendicular to the surface. Case for if I have rigid system, interconnected bodies analyzed as a single unit. If I have a rigid system, and this system consists of different bodies, so I need to analyze as a single body. I need to consider as just one body. Okay, now you can see the free body diagram, one body, regardless what I have here. So at this point I have force, and here I have ruler. This is ruler, one force perpendicular to the surface. This is the weight, this is the mass, so I need to put weight, mass, I need to put weight, mg, in connection to forces, This forces and this one depends on the the coordinates, yeah, x and y, Cartesian coordinates that I put it. Now, actually, we have conditions for equilibrium. These conditions are summation of all forces in the x-axis equal to 0, summation of all forces in the y-axis equal to 0, summation of all moments about any points equal to 0. So this is the equilibrium condition. This is the equilibrium conditions. Categories of equilibrium, or let's say the types of equilibrium. Now, for example, I have a force system and a free body diagram, and what I need of equations. If I have collinear forces like that, collinear forces, I need just one equation, summation of all forces in the x-axis equal to 0, just one equation. If I have concurrent at a point, if I have concurrent forces at one point, I need two equations, summation of all forces in the x-axis, summation of all forces in the y direction equal to 0. I need not equation of moment. If I have parallel forces, actually I need two equations, summation of x-axis equal to 0, y-x, because all these forces actually parallel to the x-axis. I have no force parallel to y. And here, summation of all moments about z equal to 0. In general, if I have multi-forces and a couple, actually I need to use the three equations. Now, how can I solving the problem? First of all, I need to specify or identify the quantities that I have. Which one are known, which ones are unknown, and which ones are known. Two, I have to make appropriate, or let's say unambiguous choice of the body. I need to choose the body that understudy, okay, to be oscillated and draw its complete free body diagram. So I need to choose the body understudy, and then I draw the free body diagram, and then I will put all the forces and the moments. 3, I need to put the a set of reference axes, okay, that's mean x and y coordinates. 4, I need to identify and state the applicable force and the moment principles equations for the which govern the equilibrium conditions for problem. So here I need to put the equations that I need to solve the problem. 5, match the number of independent equations with the number of unknowns in each problem. So I need here to say, do I have the same number of equations corresponding the number of unknowns? That means if I have 3 unknowns, I need 3 equations. If I have 4 unknowns, I need 4 equations, and so on. Then I need to carry out the solution and check the results. Actually, this is the 6 steps that I need to solve the problems in equilibrium. Here I have this example. He said determine the forces C and T. The C and T. Actually, I have this is the bridge truss joint, and I need to calculate or to know or determine the forces C and T. Now, as we can see here, Just 1 minute, please. um, Now you can see here, this is the x dash, this is the x dash, and this is the y dash, and this is the x-axis, this is the x-axis, this is the x-axis, and this is the y, this is the y-axis. Now here, if I take, this is the x-axis, this is the y-axis. Okay, so summation of all forces in the x-axis equal to 0. So in the x-axis, I'm talking about x-axis. So 8 in the x-axis positive, so it is 8 plus t cosine 40. Now this t will be in the direction of x, plus c cosine plus c sine sine 20, because this is the angle is equal to 20 sine 20. Okay, I will get this c in this direction, this force in this direction, so it will be plus minus 16, because 16 kilonewton actually in the x-axis but in the opposite direction, equal to 0. After simplification, I will get this equation that I call it or named A. Now summation of all forces equal to 0, all forces is equal to 0. Now t sine 40, t sine 40, sorry, t sine 40, okay, I will get in the direction of y, minus t cosine 20 will be in this direction, minus 3, because this force downward and the opposite direction of y is equal to 0. After simplification, I will get this equation that we call B. Now I have two equations with two unknowns. Now I can solve these two equations simultaneously, so to get T and C. Now we have another approach, but this time I need not to use the simultaneous solution. To avoid simultaneous solution, I will take, this is the x dash, this is the x dash, this is the x dash, and this is the y dash. This is x dash and this is the y dash. Now summation of all forces in the y dash is equal to 0. Okay, summation of all forces in the y dash is equal to 0. Now you can see here, this equation is 40, this equation is 50, this equation is 50. So due to this is 50, that means this angle is equal to 40. This angle is equal to 40. This angle is equal to 50. This angle is equal to 50. Due to this angle 20, so this angle is 20 as well. Now I'm talking about summation of all forces in y dash equal to 0. Now you can see C cosine 20. Okay, now cosine 20, I'm talking about this angle, not that, this angle. C cosine 20, I will get the component of C in the opposite direction of y dash, minus 3 cosine 40. Now I'm talking about that, 3 cosine 40, because this is 40, 3 cosine 40, I will get the component of that in the direction of y, but this time opposite direction of y dash, so it is minus. Now I have this force minus 8 sine 40. Now if I take this force sine 40 or cosine 50, I will get the component of that in the direction of y. Okay, so it is minus as well. Okay, what about that? I have 16 sine 40. Do not forget this equation is 50. So when I say 16 cosine 50, there is no difference, cosine or sine 40. Sine 40 or cosine 50 equal to 0. Now you can see I have one equation, one unknown, so I can get C. Now the summation of all forces in the x dash, this is x dash, is equal to 0. So first of all, T, okay, in this direction, a plus. Now I have 8. This 8 cosine 40 in the same direction of x dash minus 16, this 16 cosine 40 or sine 50, cosine 40, because now this equation is equal to 40, this equation is equal to 50. So 16 sine 50, okay, I will get a component in this direction but in minus because the opposite direction of t. Minus 3, this is 3 sine 40, sine 40, this is equal to 40, this angle is equal to 40 and this angle is equal to 50. So 3 cosine 50 or 3 sine, now cosine 50 or 3 sine 40, I will get the component of 3 in this direction, but it is in opposite. And as well I have c here, so it is c, okay, this is c, now you can see this one, c, okay, sine, c, sine, okay, now you can see this is 20, this one is 20, sine 20 or cosine 70, okay, sine 20 or cosine 70 I equal to 0. So I have one equation with unknown, so I can get the t. Thanks.